Okay, it's that time again. We have, this is new. Bobby's here. Excellent. Michael, Mr. Excitement. Yo, absolutely. His name is Yo. Nice to see you there, Yo. Professor. Okay, now, the first thing we want to look at in reviewing this is this, okay? We want to look at physical changes to review that. Now, we'll put S for solid, L for liquid, and G for gas. Okay? Yes? And we'll put arrows going back and forth. Okay? Now, the going from a solid to a liquid is, that does not work. Dos puntos. This is called melting, freezing. This one isn't working either. And then this one is called evaporation. I'm trying to get more because of work here. These things stink. And this is called condensation. Okay? Now, the energy this is increasing energy. Increase energy. Now is that, let me just check to see if that is over. Very good. All right, so that's increase energy. Okay? Now, if I'm going to go this way, I am decreasing energy. Yes? Now, something very important I left out. What happens when you go from a solid to a gas? What's that called? Do you remember? They're thinking.
Vaporization.
From the ridiculous to the... It's an expression. From the ridiculous to the, starts with an S. From the ridiculous to the sublime, sublimation. Okay? Solid to gas. This is called sublimation. Now, when you are giving testimony for, I don't even know the definition, but let's say there's a court case and you have to be interviewed by the lawyers and the judge prior to the trial. You're going to give a statement that is under oath, and they call that starts with a D.
Deposition.
Deposition. That's a deposition. So if I go from gas to a solid, I'm running out of room here. Let me change the orientation of the camera a little bit. Okay. That's called a deposition. Okay? Deposition. It's kind of sloppy though, isn't it, the way I'm writing this? Can we do it over? Can we start over? Okay, can we start over? Okay, let's start over. Make it a little bit neater. Okay? All right, now, three things. Three things. Solid, liquid, gas. Okay? Solid to liquid, liquid to gas. This solid to liquid is called melting. Liquid to solid is called freezing. Liquid to gas is called evaporation. Gas to liquid is called condensation. If I'm going to go from solid to gas is called sublimation. Okay? Let's use a different color here. If I'm going to go from gas to solid, that's called deposition. Now, this is important. This is important. This way is called increase energy, and this way is called decrease energy. Okay? Yes? Yes? So, I still want to talk about this a little bit more. I really haven't gotten to the point yet. Okay? Let me just make sure it's all on the board. Okay, it's all on the board? All right, good. Now, this is the point of all this. Okay? I'm going to erase some of the stuff on the board. Okay? Now, relative to the environment, that's what we're comparing. If I touch this, it feels cold. My hand is the environment. Okay? This is the system. My hand's the environment. This is coffee. Warm. It's warm. My hand's the environment. This is the system, okay? Now, when you're in the shower and you get out of the shower, especially when it's early in the morning, the middle of the winter, it's freezing. You can't wait until you're dry, dressed, and everything else. You feel much better. But for 30 seconds after you get out of the shower, you're freezing. And oftentimes what I do is I'll just get back in the shower without the water running just because it's warmer in there. The reason is because when the steam, which is invisible, starts to condense and form droplets, the steam is losing energy in order to form those droplets, right? So, condensation is actually a heating process. It's a heating process relative to the environment. Now, when snow forms in the clouds on a winter's day, water vapor becomes a liquid, becomes a solid. That is a warming process. This is we'll call it warming instead of heating. Same thing, but when you say warming, it just sounds more subtle. It's a warming process. But if you're getting out of the shower and it's 20 degrees outside and the heat's not working and you're freezing, it's pretty dramatic. It's not so subtle, but these changes are actually subtle. Now, when something evaporates, you're the environment, and you're evaporating sweat off of your body. That sweat that evaporates, what does it need to evaporate? It needs the heat of vaporization, which is what? Which is what? Which is what? The heat of vaporization. So that's a cooling process. That's cooling. When I go from a solid to a liquid, when I'm melting, weird, I'm melting something. I'm melting it.
But it's a cooling process.
but it's a cooling process. For instance, how do you know that? Okay. Where can you see that? Did you ever see, and you don't see it much around here because we don't have a lot of snow, but when you have snow, oftentimes you see fog or steam condensing around piles of snow. Do you ever see that? Well, what's happening there is the snow is melting. The snow is melting, and in order to melt, it has to take energy from the environment. So the water vapor that's in the air will give up its energy to give to the snow to evaporate. So you'll see this little fog. Remember, Mike, we talked about earlier in the week? You had a little bit of a hard time with, wait a second, what was it? Steam is invisible, but then what's the fog? Well, fog is really an enormous number of water particles. It's water. So, I have ice melting. Ice melting. Okay, it needs energy to melt, right? Well, where's it going to get the energy? It's not magic. It's got to get the energy from the environment. Well, what's in the environment? It has to come from something. It doesn't come from a vacuum. What's in the environment? Water. Water contains a lot of energy. So in order for the snow to melt, it's taking energy from the water vapor in the air, therefore cooling the water vapor, forming this fog. So you're condensing the water vapor and it turns into a fog. See? So this is also a cooling process. Now, make no mistake about this. Relative to the snow, yeah, it's a heating process, but relative, we're not talking about that. We're not saying snow is melting is a warming process relative to the snow, right? That's not what I'm asking. Relative to the environment, because remember this. How do you know? How can you keep it straight? Well, this is it. What's the definition of cold?
Heat being released.
Heat leaving your hand. So this feels cold, even though these two things are at room temperature, same temperature. This one conducts heat away from my hand. So it's sucking the energy out of my hand. So energy is leaving my hand cold. So when you talk about hot or cold, when you talk about a cooling or warming process, you're talking about the environment. Clear? Now, make no mistake about this. You are increasing potential energy here. You are decreasing potential energy here. You are increasing potential energy here. We'll say it's a change. We'll say it's a positive change. We'll say it's a positive change. We'll say it's a negative change. We'll say it's a negative change. Okay? Yes? And what's this heat? And what is this? What is it called? This change in potential energy going from a liquid to a gas.
Evaporation.
Sort of, close. There's a V in there. Heat of... It's heat of vaporization. Big, man. Big, big, big. Look, this value is over 6 times this value. So this is an enormous amount of energy. So that's why, and some people, I think you fought me on this. Water at 100 degrees, steam. Water at 100 degrees, liquid. Which one burns? Which one has a worse burn? The steam. The 100 steam. Why? Because what it's going to do is it's going to suck extra energy out of your hand or whatever's burned. When I was a little kid, one of the worst experiences of being a little kid, physical, not mental. Being a little kid is tough on anybody, but anyway. My mom was cooking dinner. It was late. It was like You know what day of the week it was because Gilligan's Island was on. That's the day of the week it was. Whenever Gilligan's Island was on, that's the day it happened. And you know Gilligan's Island? You never heard of it? These guys have never heard of Gilligan's Island. I feel old. You never heard of Gilligan's Island?
I've heard of it.
You've heard of it. Well, that makes you feel a little better.
I've heard of it.
Heard of it, never saw it?
That's what I mean.
It's very goofy. It's goofy. But it was fun at the time. It was kind of like an innocent, I think if it was on today, people would kind of like think it's goofy. Anyway. My mom's cooking bacon or something. And I don't know if I was messing with the pan or whatever, but the pan fell on my foot. And it was a large amount of bacon grease. Man, I can remember to this day, it was unbelievably painful. And that's a burn. Well, why is it a burn? Why is it a burn? Because that energy from that grease, where's it going, man? It's going into my foot. It's going into my foot. So the more energy that it contains, the worse the burn is going to be. Well, water at 100 degrees, that steam, is going to have more energy to put into your body. It's going to have that heat of vaporization, that increased potential energy. And it's going to be really painful. There was a movie, was it Bone Collector with Denzel Washington where he played quadriplegic?
I think so.
Was it at it? And there was the crime was someone being murdered by, I may be completely wrong.
You should be asking Jack Haddon this.
Jack Haddon's a big Denzel Washington fan.
Movies in general.
Movies in general. And I think the murder was, horrible thing, someone was strapped somewhere very close to a giant steam pipe, like a 18-inch steam pipe, enormous steam pipe, and under great pressure. And higher pressure, higher temperature, Gay-Lussac's law, plus you have this enormous amount of energy called heat of vaporization that's in there as well. And they were literally strapped very near this steam pipe that it ruptured. And the person was literally bone. The meat was just removed instantaneously from the body, and all that was left were bones. Well, why is that true? Well, because you have enormous quantities of energy in steam. Water only has so much energy because it can only go from liquid water at 0 degrees Celsius to liquid water at 100 degrees Celsius. It's a closed system, can't fit any more in, done, finished. But steam can get really hot, and ice can get really cold. But that water, and that's what makes the planet Earth so amazing, because it has a limitation on the amount of energy you can actually put in it, and it's a lot of energy. Make sense? Let's quit, and then now we're going to talk about, that's pretty much chapter 23, pretty much. And now we'll talk about chapter 24. Be right back.